My name is Mathew Robinson. Today we're going to be talking about terraforming for dynamic environments. But before we jump into that topic, just a little bit of ego stroking for myself. First is, who am I? I'm a head of site reliability with about 10 years experience in the field. I've worked kind of at multiple levels of scale, from enterprise environments to startups to kind of medium-sized companies, and both in dynamic and static environments. You can probably tell from the way I talk, I am American. If we go for drinks later, you might ask if I'm from Texas. I am not. I am from Kentucky, but I can see how it's a very similar accent, just like the only accent for British people is Cockney. What that does mean, though, is that I'm very happy to talk about anything technology related if you're offering bourbon. Today, I'm going to talk about how we implemented a fairly complex system and worked both with and around the features and failures of Terraform at MPB. And a fair warning that this talk is very information dense and we'll be going through everything effectively twice. So first, we're going to be switching between important details and high-level overviews. And then we're going to then talk through it all. And then I'm going to demo you and show you this process happening. And that'll be the second time we go through it to try and help solidify it. There will be time for questions at the end. And yes, there's a key takeaway slide so that you don't have to remember anything. You can just take a picture of that and be like, oh, I survived a talk that could have been a slide. Real quick before we get started though, how many people have worked with Terraform? Okay, great. I'm sorry. Because I have tried very hard to make this accessible to people who haven't, which is why I feel like I needed to define some Terraform basics up front. That being said, I'm probably going to tread the line between not being advanced enough and being too advanced so that no one is happy. So we'll see how that goes. The first things that are the real basics that you need to know about Terraform is a couple concepts, and that's about all we're going to go into. I'm not going to show you any Terraform code today. But first is a resource. So in Terraform, a resource is any instance of anything that Terraform can provision. And the resource block will have all the configuration for that thing. And so this is typically something like a Kubernetes cluster or a VM or a database, that kind of stuff. Next is providers. So providers are a configuration block that you set up, and also they are a separate executable to Terraform that is kind of transparently handled for you. And those actually handle the real communication that happens behind the scenes. So Terraform looks at those resource blocks, figures out what provider they belong to or are provided by, use that provider to talk to cloud APIs, Kubernetes clusters, whatever, to actually create those things using that configuration. Another important concept that we'll touch on a bit as well is state files. So Terraform keeps a state file. It has this big giant binary JSON blob that it writes out. In our case, it writes it out to a GCS bucket, which is like S3. And when Terraform apply is run, it basically looks at that state file, right? Asks the provider, says, hey, give me the current state of all this stuff. And then it looks at those things and compares them to decide what actions it needs to take to make sure that the state of your code is what is actually deployed. And then finally, the final important concept is workspaces. So Terraform workspaces are a way to keep multiple state files for the same Terraform code base. And this is supported by various backends. And so, for instance, you would have a Terraform state file that's called like workspace1.tfstate or whatever. That's mostly handled for you transparently, but that's an important piece of information. Are there any questions about this before we go on? Because if you don't understand this, you should go get a beer now. Cool. So the next piece, just to carry on with definitions and get the boring stuff out of the way, is some vocabulary. When we started this project, I'm going to basically try to condense 6 months of work and iteration and failure for you into an hour, right? But one of the things that we recognized really early on was that we needed to define these terms, because these are terms that I'm sure we've all heard, and they're incredibly overloaded, and they mean different things to different people. I'm going to say these words tonight, and I mean these exact things when I say them. So first is, what is a system? And a system for us is any combination of infrastructure and applications that together serve a single purpose. And systems are not always of the same size and scope. So tonight, we're going to primarily be talking about the MPB platform that serves our website and our backend for our warehouses. And if you go to mpb.com, you can see it running. But another one that we run is Jenkins and its associated infrastructure. We call that internal services. So those things are a system conceptually because it's the infrastructure and the app. An environment then is a isolated deployment of a system with a specified configuration. And for us tonight, what we're going to be talking about, that isolation is achieved through the use of separate GCP projects. So you could use AWS accounts or various other ways to do this in other cloud providers. That's the way we do it. And environment tier, and we're going to talk about this a little bit more on the next slide too, but an environment tier describes the quality of service expected for a particular environment. And roughly this goes something like production, staging, and development, where production has the highest quality of service. And that encompasses everything from the type of hardware provisioned to the support level guaranteed, right? In terms of, obviously, production has the best, fastest hardware, no expense spared, right? And we also get a ring if it goes down, yeah? Also, if you start calling pages ring rings, it makes them less scary. Cool. Now, what I want to talk about is what is actually a feature environment, because you might be wondering why environment tier and environment are separate concepts. And that's really important because feature environments are dynamically created and managed environments which deploy code from your feature branches. So the reason you have to separate those concepts is because when you start operating on this model, you end up having a development environment per branch that's active, yeah? And so you don't have this kind of static model that some of us may be familiar with, right? Where you have a production environment, and some of us are lucky enough to have a separate test environment, and then some of us are yet again lucky enough to have a development environment. But in the model that we've adopted here, we have somewhere between 0 to 50 development environments at any point in time. I'm hoping that most people are familiar with that kind of traditional, dev test production model, because we're going to be talking about that and contrasting that with what we've done tonight. But I think the most important thing about why you would decide to go down this path to build feature environments is when you start doing service-oriented architectures, actually running the whole system on a laptop becomes very difficult, very complex, right? And feature environments can save you from that. And they also give you something that is actually truly like production. When Docker started to gain traction, people were like, oh, you can run your app like it's in production. And those people are dumb because they forgot about things like network segmentation, firewalls, security, databases, like all that stuff, right? There's a lot more to what happens in production than just the app. And so a feature environment gives you all of that in one place in a way that you know it's configured and works the same as your production environment. Now, before you can start moving on to this wonderful world of dynamic environments, you need to be able to replicate the environments you do have. And to do that, using infrastructure as code is the way to go. I think the industry is all well agreed on this. If you don't agree with that statement, I would love to talk to you. But you have to kind of invest in tools like Terraform or CloudFormation. One common misconception that we hear a lot, and I don't want to get asked about later, is that tools like Ansible are not infrastructure as code. They're more configuration management. And so we do use Ansible here at MPB, but it happens at a totally different stage, a totally different process, and it doesn't really feed into the things we're going to talk about today. That being said, that line can definitely get blurry in some situations, and we'll definitely be talking about that too. A good example is when you're using Terraform to deploy things, you'll want to variabilize some parts of that deployment and provisioning, such as like how many replicas to run for any given service. And my rules for variabilizing Terraform sanely, and this has saved us a few times, is obviously use as few variables as possible. Prefer flags to values, so use booleans instead of complex types. So you want an on-off switch, not a slider. Yeah? And then always default the variable to your lowest environment tier to cut down on configuration creep. And this is to solve a problem that we had with both our original Terraform attempt and our original continuous deployment pipelines, which is that the more things that are configurable, the more configuration files you have, the more the drift of that configuration happens between those environments. And you end up managing all those files, and it gets very tedious, and it becomes very easy for them to like not be even diffable anymore because they're not the same. So those rules will save you from that because you no longer have to configure your dev environments. All of your variables are defaulted, right? Terraform apply on any given thing builds a dev environment. And then you only have to worry about your longer lived environments. This is really quite important to handle the dynamism that we were trying to achieve here. Because obviously we can't go create a TF-vars file every time we want a new environment if we want this to be truly automated, truly dynamic. Cool. Sweet. The last kind of base layer that we need to build up before we start talking about the actual system is this kind of mindset shift that happened for us. And that's thinking functionally with pipelines. So I'm definitely guilty of this, and I imagine everyone who's ever tried Terraform is guilty of this the first time. But they go, Terraform is a tool for describing my infrastructure. And I've got a staging environment and a production environment, so I'm going to describe all my infrastructure. And now I have done infrastructure as code. And that's bad because first off, you have a lot of copy paste. You get into that configuration drift thing, and you can't kind of then replicate, right? How do you then take that staging environment and turn it in, like create another dev environment from it? Well, you have to copy a bunch of Terraform code, right? And you don't have any real separation. If you instead think about your actual entire Terraform code base as a pipeline that takes inputs and produces outputs, you then have something that is a template for doing something, for provisioning something, and that template takes inputs and it configures what you want. On top of that, it then kind of builds every Terraform code base into a component, which can then be composed together to build bigger, larger pipelines, and it allows you to have a lot of flexibility. This has saved us a bunch. We've been able to do certain projects very quickly because we have a bunch of little components and we can mix and match them in different ways. Any questions about that? Again, this is one of those ones where if you've glazed over, it's beer time. All right, cool. And now we're going to start talking about Terraform and why it sucks. So, as I hope we all know, because I assume some of you at least Googled Terraform, even if you hadn't worked with it before, Terraform manages resources, and that includes things like accounts and projects, right? It can provision both the things and where they live. However, there are actually some dependencies that are impossible to model in Terraform. So at my previous job, I worked on a C++ build system, and Terraform at its heart is just a build system for infrastructure, and it is a way to model dependencies, right? And to resolve them in the correct manner. But it can't do that for everything. So this diagram describes one of those scenarios where if you have a single Terraform code base, this is actually pretty much unresolvable. And there's an open issue about it, and they said they won't fix it. So don't worry about it. But if you have your GCP provider and your Kubernetes provider in the same code base, and you want to define a Kubernetes cluster resource, right? And also a Kubernetes secret resource that goes on that cluster. So you have a dependency between the cluster resource and its provider, obviously, because it needs to be able to go out and provision itself. There then is a dependency between the Kubernetes secret resource and the Kubernetes cluster, because it needs to know that it's there before it can be put onto it, of course. And the Kubernetes secret resource depends on the Kubernetes provider. But the Kubernetes provider needs configuration too. It needs to know where that Kubernetes cluster is. And so that provider depends on that Kubernetes cluster resource. If you go and build this, and this is really nefarious, if you build this up so that you do your cluster resource in your provider and you provision it, it goes out, and then you put this in, and then you put this in, and it works. But as soon as you try to apply that on a fresh environment where that cluster isn't there, Terraform tries to initialize this Kubernetes provider, and the provider goes, well, I can't talk to anything. There's nothing there to talk to, which is true. So Terraform has not lied to you. It has just done a very dumb thing, because it should know that, but it doesn't. And that has to do, sorry, I shouldn't talk when I am pulling my sleeve. That has to do with the actual underlying process, the way Terraform works. Is the very first thing it does is it tries to initialize all the providers, because it grabs that state file, initialize the providers, and then ask them for the current state. And that's before it tries to do the planning or anything like that, where it actually tries to build dependencies and resolve them. And it can't do that because this thing goes, I can't talk to blank. Cool? This is going to come up a lot and talk about why we structured things the way we did. But this is also very important. And I hope it's very clear now that I didn't put any information in these slides that isn't important, okay? I don't know why I keep saying it. Cool. So now, moving on to the actual pipelines that we built and how they are composed. The first pipeline is the Bootstrap Pipeline. It's gone through various names and iterations over its lifetime. Important to note as well that while we organize Terraform into pipelines, we split those pipelines up into stages so we can deal with that dependency problem on a smaller scale. Because otherwise you'd have to build a whole nother GitHub repository, a whole nother CI pipeline, a whole nother bunch of stuff. And so just use stages instead. And we'll talk a bit about what that looks like. Excuse me. This first pipeline, it's only a single stage, and it kind of contains everything that's not really part of provisioning our normal systems, right? So if we have a system for MPP platform and a system for internal services, there's some common things that are shared there that they're both going to need, right? We said that every environment is a deployment of a system with a specified configuration, and that is achieved through GCP projects. But we don't need to redefine the wheel on how we build a GCP project and all the other stuff, IAM roles, things like that. So we built a separate pipeline to do that. The Bootstrap pipeline, and this is important later, is uses Terraform workspaces per project so that any of its outputs can easily be referenced and reused by downstream pipelines. And that's how the outputs are managed. There's not really a whole lot of exciting stuff here, but this is where we decided to put IAM and all of the kind of pre-provisioning stuff. The Bootstrap pipeline, then when it runs in our pipeline runner that we'll talk about later, it triggers the provisioning pipeline. And once that project has been built using the same workspace name, it passes that down so that the workspace name is then the same again inside of the provisioning pipeline. And this allows us to reference runs of the pipelines across pipelines, which is a very difficult sentence. And I thought about a lot of ways to say it. Does it make sense? So if I used a workspace in the Bootstrap pipeline and it triggered the one in the provisioning pipeline, they'll have the same workspace name. So I can say this state file corresponds from this pipeline to this state file in this other pipeline. I see some heads nodding. I see some people nodding off. Okay, cool. The provisioning pipeline here really is the kind of meat and potatoes of our deployments. This is where almost everything interesting happens, and we've got a very similar setup for every other system that we have. The first is that it's actually split up into multiple stages. And so that allows us to provision the infrastructure and deploy the applications onto that infrastructure. The first stage is 10 infrastructure, and that handles all the networking, Kubernetes clusters, VM instances, buckets, and basically anything base layer, if you will. And if you're wondering why it starts with a 10, that's because some of us will remember the good old days of init systems where that was how you indicated order. And that's because these stages are not a Terraform concept, right? This is some kind of software architecture that we have applied to it. And those numbers are so that when humans look at those stages in that code base, they know this is the order I have to do the thing, right? And we initially only started with 10, 20, and 30 and left ourselves some room to expand out, which we had to do. One of the first places we had to do that was with 11 databases, because the databases used to be part of the infrastructure. However, the GCP provider cannot model the dependency between the service networking setup in GCP and the Cloud SQL databases. It knows that it needs to be there, and it will report that it is there before it is actually there. And so this again is one of, I think, one of the pitfalls and problems with Terraform is that because the providers are all built by other people, they're not managed by the Terraform project, you have a wild variance in quality and behavior. And so you are oftentimes going to have to be thinking about what providers you're using and what the quirks of them are. And they have their own issue trackers, which makes it even more fun to try to find minute details like that. So to solve that, obviously we split it into another stage. The following stage then is the cluster config, and that deploys any kind of global Kubernetes resources. I'm not going to bore you with a bunch of Kubernetes nonsense today, but there's things that you have to deploy per cluster just so that apps can function at all. So an ingress controller is a really good example. If you're not sure what that is, you Google it, but it's basically a HTTP proxy. So it's like Nginx effectively for all your apps. Other things that go in here, monitoring stack, any other kind of like NFS server provisioning, storage classes, that kind of stuff. The following stage to that is our cluster-wide CRDs. So CRDs are custom resource definitions, which is where you can kind of teach Kubernetes how to do new things, which we've done 0 of because it's very hard. But these things that we deploy here, they do that for us. And so we have to provision some instances of that. And specifically here, the main thing that we deploy is our Let's Encrypt issuer so that all of the apps can go to Let's Encrypt and get SSL certs. Following on from that, we have 30 applications, and this is where the magic happens, all right? Once this stage is done, you can buy and sell photography and videography equipment to your heart's content. this is where all of our services get deployed. And last time I checked, it's about 15 different packages that get deployed because we do a service-oriented architecture here at MPB. I'm not going to list all of them, but I will reference them by name at some point in the next slide. And then finally, we have the Bootstrap app stage. That is for feature environments specifically. So on your longer running environments, you might have cron jobs and other things that like build up data that you need or serve. So for us, for example, our taxonomy for our website that like tells you what models belong where and all that stuff, that tree, that's something that gets generated by a cron job every so often. But here we force it to kick off right away so the feature environment is ready for developers and QA testers as soon as possible. Another good example there is our search indexing. We start indexing things in search so that the site has products available because it wouldn't be very useful otherwise. All right. Is there any questions about that? Cool. All right. This is, to me, probably the most complex thing that we had to do. And it took us a while to figure it out. And I'll be honest with you, there were points and times we were like, I don't know if this is actually possible to do. But dealing with application versions. So, you know, the first instinct when you get to that is you're just like, well, I'll just make them variables, right? I've got 15 services. I'll make 15 variables that has like service name version, service X name version, service Y name version, and I'll just configure them all, right? But the kind of issue with that then is whenever you want to build this pipeline, what's the dev tier default for that, right? If we go back to our variable rules from the beginning, we have to come up with a dev tier default. Well, you don't know what the dev tier default is because that's a moving target all the time, right? And you don't want to be in the business of constantly updating this stuff every time a deployment happens. You want continuous deployments, right? And we solve this by, frankly, a hack. We abused Terraform in ways that it's not meant to be used, but it does work. And so what we decided was, well, the provisioning pipeline, its inputs, if you think about its inputs, we want to be able to input a single services version. And then we want Terraform to figure out the rest of it for us, right? We want to be able to say, give me service X 1, 2, 3, and then figure out the rest. And that allows us to incrementally build up an environment as we continue to deploy new versions to it. But it also allows us to get a starting point. So the first thing we did was we added the variables for everything, and we defaulted them to null. And then we added logic for determining what any given service version is. The first is, have you set this variable to a value? Because obviously, if you've said, I want that, well, then that's what you want, right? Then we say, do I have an existing deployment of that in my state file? And if so, I'm going to use that version so I don't change anything, right? We don't want to revert stuff accidentally. We don't want to upgrade stuff accidentally. And then the final bit of logic is, okay, well, if you've not said you want this, and I haven't deployed it before, then I'm going to go look at the staging state file, and I'm going to pull that version out of there, and that's what I'm going to use. And so when you build then your feature environment, your dynamic environment, and you say, I want the transaction service version that's from this feature branch of the transaction service, it then will give you that. But then for all the other 14 other services, it will go get you the staging versions. And your feature environment then will be fairly representative of your staging environment, other than the changes you've made. That does have a little bit of caveat, right? That logic makes it so that every state file becomes the source of truth for application versions, and it can be built up incrementally. What that means then is that if you use Terraform destroy, or you lose that state file, you cannot reproduce that feature environment easily. That's the big downside to this method, right? With something like a GitOps or whatever, you have a little bit better kind of reversion and control and ways to do like time walking, but you also have a lot more manual work and a lot more like ways for things to go weird. Whereas this is for the most part using Terraform state files the way they're meant to be built, right? Is there any questions about that? Okay. Okay, that's fine. You look like I've offended you, and I don't blame you. All right, this is unholy. Okay, let's get that clear right now. Cool. Now, we've now talked about kind of how all these pipelines work. And this here diagram is a very simplified version of what we call the platform pipeline. And this is the pipeline that's built of all the other pipelines, because we really like using the same word to mean two very different things. So you can see here how all of the different CI pipelines for the various repositories and services, the very last step of those then is to feed their inputs into the Bootstrap pipeline, which is what kicks off various environment deployments and provisioning, right? If it's a build that's running on the main branch, it will know that it needs to go to staging. And if it's a build that's running on a feature branch, it knows it needs to go build a feature environment. There's not a lot to talk about here. All right. Okay. I see a lot of bright eyes. Cool. The one other thing that I think is really important to talk about before we start getting towards the end of this is the new promotion pipeline, because you got to think about how all this stuff feeds into each other in terms of getting code from a feature branch into production, actually. And obviously, in a more kind of traditional static setup, the way promotions work is you go, hey, Mr. sysadmin, can you put my dev one in the test one, right? And can you put the test stuff in the production stuff? But obviously, we want to automate all this stuff, right? I don't want to be messing with it. So what that ends up looking like is that you have n number of feature environments, where that represents any kind of user story that's in progress in development. That obviously has tests on commit, right? They've got their CI pipelines, they've got linting, they've got automated testing. If that's not happening, don't build this, okay? You got to have at least some quality checks before you even get into a deployment phase. And then it has an automated build and an automated deploy to the feature environment. And what happens is that developer puts a pull request up to say, hey, I want to merge this branch back into the main branch because my code's perfect, because I'm good. Which is almost never true, but then it goes through code review and then it becomes true. And then they will hit that merge button. It puts it into the main branch. That then again runs the automated build, right? That runs that CI pipeline again, automated deploy, that goes to staging, that kicks off an automated regression test, because we have a bunch of test automation that like actually goes and QAs the site, little robots. And then if that passes with a satisfactory percentage, then it will get promoted into production eventually. But all of these quality gateways, they're automated. They're triggering each other using the same kind of pipeline concept, but not with Terraform. Cool. Any questions about that? All right, last piece of the puzzle is the pipeline runner. You know, I've talked a lot about pipelines. I've talked a lot about code bases, but where and how do they get executed is really up to you. You know, you have a multitude of great CI/CD platforms that you can do this with. GoCD, JenkinsX, TeamCity. I mean, just to name it, I wrote those down off the top of my head, and I know there's more than that, right? I'm sure someone will tell me about OctoCAD or something of that nature as well. For our purposes, we chose Jenkins, and I felt like that, you know, bore a little explaining. And the first reason is that it has an excellent pipeline visualization UI. Yes, it's a plugin. No, Jenkins looks like crap out of the box, but there's a great plugin for it. It also had two really important characteristics as well, is that had easy deployment onto Kubernetes. There's a Helm chart for it, and that made it easy for us to deploy it the way we know how to deploy stuff. And it's self-hostable. And because we could then host it on Google Kubernetes Engine, it meant that we could integrate it with GCP in really easy and obvious ways. For example, one of the questions we had when we were evaluating these tools was like, well, if it's a hosted service, a SaaS service, right? How do we securely give them credentials to end the company, right? Because that Terraform stuff can do that. Because it's provisioning everything, it can destroy everything, right? It's basically an SRE. And so do we trust someone else to do that? Well, maybe, but not for us. And in the end, it really was easy to integrate it with IAM because it has this feature called workload identity. So you can just be like, this particular pod has a service account and no one else can use it, which is really cool. And then the last point is that it was customizable and highly flexible, so scriptable. And I think the last point is really important. You know, when we started this, we were doing something that was totally new to us and was not well documented. Like there isn't a lot of like, there's no blog out there that says how to do this crazy thing, right? And it's very difficult to Google for. And so we didn't want to commit to a tool like, TeamCity or JenkinsX or something that JenkinsX, by the way, is not Jenkins at all in any way, shape, or form. I don't know why it's called JenkinsX. So just to be clear. But we didn't want to commit to a tool like that and then get 3 months into this project and realize that it can't do something that we were kind of counting on and have to rethink the last 3 months of work, right? Jenkins, for better or worse, could be bent to our needs and could be made to do damn near anything we wanted it to do. And so that was a big, important piece for us. That being said, though, now that we've done this before, right, and we know exactly what we're trying to accomplish, I don't know that we would make that same decision, but I do have to also admit that Jenkins has been pretty good to us. So, it's not been too terribly unstable. Darren doesn't look happy about that statement, but but it's been fairly stable. It's worked pretty well, and it's been pretty fast. So, cool. Before we get into the demo, is there time? Do you want any questions? Great. Okay. I'm just going to run you through a pull request that I put up the other day. Okay. I wondered if that was disconnected or not. I'm going to run you through a pull request I put up the other day, if I can find a way to do it around all these Zoom controls. There we go. Great. So Toucan, for context, is the front end for our customer-facing website. So if you go to mpp.com, you're working with Toucan. That's the thing we're seeing in the PR for here. So I put up a PR to make the website have accurate information. And I said, everyone should ignore this PR. And then, of course, the snarky front-end dev was like, I'm not going to ignore this, and I'm going to put code review comments on it. This then, you can see down here, boom, says all checks have passed. And if you hit show all checks, you can go to the details. That will open this link that Lord help me, I hope works. Okay, great. And this shows the CI pipeline. So when we were looking at that platform pipeline diagram, those CI pipelines, that's this one, right? Now I've cut this down very hard to make it faster because I was lazy and I didn't want to abide by JavaScript linters. And so you can see that kind of the end of that pipeline really is what we're looking at here. And we see tag release, build the Docker images, build the Helm charts, and then trigger a deployment. And one of the real kind of hidden benefits of feature environments as well is that now your developers can't break deployments because their PR needs a green check mark, and that green check mark only works if it deployed somewhere. So that was a big win for us as well. You can see that this deploy step, I've got it highlighted there. It triggered downstream pipelines. And it's triggered the Bootstrap project and deploy MPP platform, which, if we go to the Bootstrap project, which again I hope loads, there we go. It just verifies that it's ready to deploy, and then it deploys the project, right? And that CI pipeline upstream said, this is my branch name. And then from the branch name, it determines what the environment should be called. And so one of the rules we said was, when you're naming your branches, you got to put the Jira story number in there so that you can correspond all the deployments across repositories, right? So if you've got a feature that is in a backend repo and in a front-end repo, you got to name those branches the same on both of them so that it knows to deploy to the same place. Okay? One important thing it does here is updates the modified date, but that's about it. And you can see in this case, because the project was already there, this only took 49 seconds to run. It's very quick because Terraform goes, oh, I got nothing to do. This then, the last thing that, or the next thing that happens from the CI pipeline is it calls deploy MPP platform with basically the same information. And this is that provisioning pipeline, right, with a nice visualization. And you can see a lot of the things that happen. So first, again, we validate that we're ready to deploy, that we got all the parameters we were expecting, and that like they have values, because you would think that Jenkins would do that for you, but it doesn't. It deploys the bucket backup project. That only happens for production deployments, but all of our GCS buckets for production, we back up somewhere else, and that is the stage that does that bit. Deploy 10 infrastructure, which is the stage we talked about, deploys those databases. And then, really importantly, when it deploys those databases, part of that process is if it's a feature environment, it loads the latest production backup into that database using Terraform. And that's a really cool Cloud SQL feature. And so once those databases are loaded, though, they've got customer data in them. And so that stage then writes out a file that means that this next stage knows that it has to go sanitize those databases, and it runs a SQL script to go and basically strip all the customer info out. While that's happening, we then move on to the 20 cluster config stage, which is where we deploy those things like the ingress controller and the monitoring stack and some of those kind of global Kubernetes resources. Finally, cluster-wide CRDs, then applications, and then we bootstrap those applications with data. That is how my feature environment for my stupid PR got built and deployed and provisioned. And part of this infrastructure step as well is to register DNS names in Cloudflare. And so I wanted to show you, this is what the main website looks like. So this is mpb.com. And then this is my feature environment with my changes to Toucan. All right, and you can see that it deployed the code from my branch. Cool. That is the demo. Does anyone else want to watch it bounce back the other way? All right, cool, that was sweet. All right, great. So key takeaways. I know that most of you probably heard about half of what I said. So this is the stuff to remember. If you want to take your phone out and take a picture of a slide, that's the one, all right? So first is, think of your Terraform code as pipelines, which take inputs and produce outputs. That will instantly get you to a better place. You will have a composable system. You should think of your environments as a single output of all those pipelines in aggregate, right? You should have a concept of a platform pipeline like we do. All right, okay. By extension, then, you should never use a single Terraform code base to describe multiple environments at once, right? Terraform code bases are a template for building an environment. And the thing about a template is that you have to give it inputs to render out to what it should be. And finally, use Terraform workspaces to apply your pipelines multiple times. And you should definitely variabilize on that as needed and use it to reference remote state files for interstage and interpipeline communication. So we have a lot of stuff that's like, do delete protection if the stage of this project is production, right? Like that's a very easy thing, and you can get that from the workspace name, you can get that from all kinds of stuff.